Hey, for today's video, I wanted to get you started on factoring. I'm probably going to make a few videos about factoring because there's a lot of different expressions that you can need to factor, and there's a lot of different methods for factoring those different kinds of expressions. So it'll probably take up a little time. Today's video is specifically about factoring quadratics, and I'm just going to cover two situations. One, where you're factoring something where there's a common factor in each of the terms, and two, where the leading coefficient, and I'll explain that a little in a second, but where the leading coefficient is 1. So that's what we're going to do today. So first thing I want to share with you is that there is a standard form that we write quadratics in to make it easier to look at them and talk about them, okay? So the standard form of a quadratic. The standard form of a quadratic puts the highest degree term all the way over on the left and then goes down in degree from there. So in other words, it'd be like, for example, x squared plus 2x plus 3. So since the x squared was the largest term, of the second power instead of the first power, right? We put that over on the left, okay? So that's standard form of quadratic. So if you, by chance, you end up getting some expression, say this originally came to you in a problem, it looked like this, and you should definitely work with it a little bit so that it's in standard form, so that it's easier to look at and so that you can kind of make it familiar and be able to refer to the coefficients, okay? Now, if you recall, coefficients are these numbers in front of the terms. So, for example, let's say I had another quadratic, let's 2x squared minus 3x plus 7, okay? We would say the coefficient of this first term is 2, and the coefficient of the second term is -3. Coefficient of the constant term is it's 7, it's the constant at the end. We talk about the leading coefficient. That's just the coefficient of that largest degree term. So that's the leading term, and so 2 is the leading coefficient. Okay, awesome. Just a little background on some terms that we're going to use, some nomenclature. So, I want to remind you that factoring, you can basically just think of it as like the reverse operation of expanding. Let me just tell you what I mean real quick. So for example, if I took a couple binomials, two-termed things like x plus 1 and x plus 2, and I wanted to expand those with binomial expansion or FOIL those, I would say first, outside, inside, last. That's that acronym to remember how to expand them. So first, outside, inside, last, that would be x squared outside plus 2x plus x plus 2. Okay, and then I could combine those middle terms, right? So this is expansion, the opposite of factoring, okay? So when we're factoring something, they start out giving us this, and we're asked to go the other direction and figure out what binomials would multiply together to equal this thing that we're trying to get, okay? So today, we're going to look at cases where that leading coefficient is 1, which is actually, that's quite a few cases, especially when you're learning quadratics, that's a lot of times where you'll start. And notice, anytime that leading coefficient is 1, It's because the binomials each had x in this position. They didn't have anything else. They didn't have 2x or 3x. Otherwise, when those would have multiplied together, okay, to give us that first term, we would have gotten something besides just x squared. Okay, so there's going to be an x in each of those positions. That's great. Takes away a lot of our work. And then what we have to do is we have to identify some numbers which when they're multiplied together equal 2, and when they're added together, when they're multiplied together equal 2, and when they're added together they equal 3, okay? So, and we just did this one, so we know exactly what the answer is, but, you know, as it turns out, 1 multiplied by 2 equals 2, and 1 plus 2 equals 3. And I'm just going through this like this so that you can, you know what to expect as we go into our next problem. Okay, but before we do, let me take just one moment to remind you of the easiest possible way to factor anything, and that is to factor out a common factor. I want to remind you to check for this first because it's really nice and easy, and if you forget to check, it'll make your life harder for no good reason. So, if you start with something that you know you have to factor, and let's say it's, let's say, I don't know, 2x squared plus 4x, and you're told you have to factor. Well, always look first for any common factors that are in the expression, all the terms in the expression. In this expression, both of the terms have the factor 2, and both of the terms have the factor x. And so we can just factor out those common factors out of each of the two terms, leaving 2x plus 2, and all of a sudden we're done. Okay, that's all the more factoring we have to do. A lot of the time, a student who's maybe not very familiar with factoring and they're just learning factoring, they'll make their lives a lot harder by forgetting to look for that. So please, the number one thing you always do when you're factoring is look out for common factors. Let me give you one more example of how that'll make your life easier. Suppose you get this problem to factor. Suppose you get 2x squared plus 20x plus 48. Okay. You, being a very smart math student, you would say, oh, wait a second, there's a common factor in each of these terms, and you would start off by factoring that out first. So this you'd say equals 2 times x squared plus 10x plus 24, leaving yourself a much easier factoring problem, okay? Because you don't have these larger numbers, 2, 20, 48. Now you've just got this nice 10x, or x squared plus 10x plus 24 expression to factor, okay? So number one thing you do, look for common factors. Now you'll notice that this thing that we got out, x squared plus 10x plus 24, it is a quadratic expression with a leading coefficient, that's right here, of 1. It's as if there's a 1 there, right? 1x, that's how many x squareds we have. 1x squared plus 10x plus 24. Okay, so that's what we're about to do. We're about to learn what you do in those situations. So we got this x squared plus 10x plus 24. And remember, we are looking for some numbers that multiply together to equal 24. And they sum, or they add up to 10, okay? So we're on the hunt for those numbers. And here's how I do that. I write that 24 over here, and I go looking at all the different factors of 24. So I could say, I always start like this. 1 times the number, 1 times 24. Certainly those two numbers multiplied together equal 24. And then I go up to the next, prime factor of 24, which is 2. So 2 times 12, that works. Let's see, and 3 times 8, and 4 times 6. Okay, so I do that. I don't know, I write them in these V's. It's just the method I use. And then you look through those and you say, which of these can add together to be 10? So looks like the 4 and the 6 will do nicely because 4 plus 6 is 10, so that works pretty well. And then remember, since the leading coefficient is 1, we know that this position of the binomial is just going to be x. So that's always nice and easy when this leading coefficient is 1. We just put the x's there. And then we just selected those numbers that we needed, the 4 and the 6. So that's it. That's all you have to do. So as soon as you find those numbers, those are the numbers that go in those positions. You got to be careful about the signs, not for this particular problem because everything was positive. By the way, it's positive. You can't quite tell because I put that circle there. But anyway, everything's nice and positive. Just to convince you and remind you what's occurring, I'm just going to go back and prove that we really did get the right answer by foiling this. First, outside, inside, last. First, x squared outside, 6x inside, plus 4x, plus last, 24. Remember those combined. It's x squared plus 10x plus 24. Okay, so we really did get it. We've got the two binomials, which when multiplied together equal this expression that we started with. Okay, and that process is called factoring. So let me give you another example just another example to work through where not everything is positive, okay? So still, it's the same situation where we're looking for two numbers which when they're multiplied together equal negative 27 in this case, and when they're summed equal negative 6. So that's what we're searching for. And again, I'll start pretty much the same way. I'll say the 27, and I'll go 1 times 27. Oh, by the way, that's negative 27. So now I'm thinking about signs a little more than I did on the last example. I want a negative 27. So what we'll do for that is a positive 1 and a negative 27, or a negative 1 and a positive 27, right? Then the next things it'll do is like a 3 and a 9. And again, I can do a positive 3 and a negative 9, or a negative 3 and a positive 9. And I'm looking for sets of numbers that are going to sum to negative 6. And I think I find them here in this positive 3 multiplied by negative 9, right? So positive 3 multiplied by negative 9 is negative 27, and when I add them together, negative 3 plus negative 9 is negative 6. So I found them. And remember, since the leading coefficient is 1, the first bits of these binomials are really easy. They're both just x. And then we say our plus 3 and then minus 9. And then just to check it, we could go back and check it. When you're first learning, it's a pretty good idea to go back and check and just make sure that you've got it right. And as you get more confident, you don't need to check if you're getting them right every single time. But it's always good to maybe run it back the other direction if you're first learning. Okay, so we saw two examples where the leading coefficient was 1. I think that's probably enough. But tomorrow, what I'll do is I'll show you methods, just one method really, of what to do when the leading coefficient is not 1, something other than 1. So we'll look at that in tomorrow's video. All right, thanks for watching. See ya.